All right, so guys, I'll do some questions from number 1 for you, 2.7, Calculus 30. So implicit differentiation, this is basic implicit differentiation questions. So remember that the preferred variable is x because it's the derivative of y with respect to x. So that means that x prime is 1. That means that y prime has to stay as y prime, okay? And we'll use Newton notation with the primes instead of the Leibniz because it's just a little bit cleaner. So with the first one here, the first term is x squared, so we take the derivative of the first term, which is just 2x. Then we subtract the derivative of the second term, but this is y squared, so we have to use chain rule here. Y is like a foreign function, okay? We can't just differentiate y prime to be equal to 1, doesn't work that way. So this is going to be 2y. Chain rule says then I multiply by the derivative of the inside, which is y prime. Okay, so that's very, very, very important that you understand the difference between the derivatives of those two. They look very similar, but the derivative of y is y prime. The derivative of 1 is 0. And now what we want to do is we want to isolate our y prime. We just have it in one spot, so this is going to be easy. So let's get this term over to the other side because it's negative right now. So I'm going to make it 2y y prime on the right side equals 2x. Now I'm going to divide by 2y, both sides, and y prime is equal to, 2's cancel out, it's x over y. Okay, so y prime should be equal to x over y. Any questions about that one? For those of you that got that, does that look right? You did that, that's what you got?
The next one, number C, 1C.
Okay, I'll get to it. I'm going to do B. Okay, I'm not just doing your assignment questions. I'm going to do some more. But
I'm actually confused now.
On C?
Yeah.
Yeah, no, I'll get to it. I'll get to it. So let's just get some more practice with the next one's very, very similar. That's why I want to do this one. So 3x squared, that's the derivative of x cubed, plus 3y squared times y prime. So remember the chain rule with the y's. Equals 0. So I'm going to leave the y prime term here. It's going to be negative 3x squared on the other side. Now I'm going to divide by 3y, both sides. And y prime is going to be, the 3's divide out, negative x squared over y. I'm just going to double check my work. Yeah, over y, hang on, squared. Why did I not write that squared? Oh, missed my squared. That's what looked funny. Okay, so that's your derivative for B. All right, so I'll do C here next then. Okay, so x times y equals 4 is what C is. So we have a multiplication there, so we have to do product rule. So that's got to be x times y. Treat that as a product. So that means we take the derivative of the first, which is the x part, which is derivative of x is 1. Derivative of the first times the second, just plain old y, plus the first, that's x, times the derivative of the second, which is y prime. Okay, so you got to do product rule here, and then that equals 0. So remember, y is a foreign function. You have to do chain rule, you have to do all that sort of stuff. So here, again, I want to isolate for y prime. So I'm going to subtract y from both sides, get rid of it over there. And y prime is going to equal to negative y over x. So that if you want to find the slope of the tangent line, you have to put in both the x coordinate and the y coordinate of the point. Okay. Okay, any questions about that one? That's C. It looks like E, but that's C. Okay. Okay, D. So D is up here. So the derivative of x squared is just 2x. The derivative of xy, well, we just did that. The derivative of xy. So that's going to be 1 times y plus x times y prime, product rule, plus 2y to the power of 1 times y prime equals 0. Derivative of 1 is 0. So now that we have the derivative of y in two places, I want to isolate those two terms on one side and factor out that y prime. That's how I'm going to separate it. So I'm going to put a negative 2x on that side, and I'm going to put a minus y on the right side. Get rid of those two terms. And then I'm going to factor a y prime out. So the y prime is going to be factored out of these two terms that are left. And I've got x plus 2y there. So that y prime, when I divide both sides by x plus 2y, I'm left with this, but I'm going to factor a negative out because a negative 1, because that's pretty obvious there. So negative 2x plus y over x plus 2y. Now those are close to being the same, but they're not the same, right? So you can't divide these factors out. They're very different, although they look pretty close. So let's see, negative plus 2. Yeah. If you had the y first, the y plus 2x, like you might see in the solution manual, that's totally fine. As a sum of terms, the reverse order doesn't matter. How are we doing so far? We good? Any questions about any of these four so far? Okay, let's do E then, I guess. Yeah, question? Oh, you're just waving at someone? Oh, okay. Okay, good. All right, x cubed plus y cubed 6xy. Okay, x cubed plus y cubed equals 6xy. So this is E. So let's take the derivative of this one, and I'll get f out of the way for now. So I have 3x squared plus 3y squared times y prime, chain rule. Now this 6xy, you can do this two different ways. You can take the 6 out and then take the derivative with respect to x of xy, and then do all this and then just multiply everything by 6. Or you can treat the first function as 6x, and then the second function is y. That doesn't really matter. It doesn't matter at all. So I'm going to treat the first function as 6x, and the second function as y. So the derivative of the first is 6 times the second, it's y, plus the first times the derivative of the second. Okay. So I see my y prime terms. There's one there and there's one there. So I need to get those on the same side so I can factor that y prime out. So let's see. I'll leave this over here, 3y squared y prime. I'll bring this one over, minus 6x y prime. I'll take this over to the other side as a negative 3x squared. And then I have a 6y here. Okay, I think that's good. Take a y prime out. I'm left with 3y squared minus 6x. And I'm going to reverse this just because it looks a little bit better with no negative in front. And then I'm going to divide both sides, so I'm going to end up with y prime, and we'll do some factoring here before we're done. And let's do that actually now. I'm going to take a 3 out of both of these up top. So 3, that's 2y minus x squared. And I factor a 3 out of here. And I'm going to divide that by this, which takes another 3 out of there, and I have y squared minus 2x. Which is great that we did that, because it looks like these 3's should be able to cancel out then, right? So the 3's cancel out, and sure enough, y prime is just this right here, 2y minus x squared over y squared minus 2x. Order doesn't really matter if you have the x term first or the y term first. It doesn't really matter. Okay, so any variation of this. Also, what I mean is it could be negative x squared plus 2y, and it could be negative 2x plus y squared if you want. That's the same thing. But, okay. This shaping up okay? You have any questions? It looks like I have, is this the F? Yeah, I have F right here, so I can do F for you as well. So this one looks a little trickier maybe. It's got more y's and it's got a product rule there. So let's try and tackle this one. So the derivative of this first term is going to be a product of an x function and a y function. So the derivative of the first is 2 times the second, y squared, plus the first, which is 2x, times the derivative of the second, so that's going to be 2y, y prime. Minus 3y squared, y prime, equals 2x. Okay, in agreement with that? Is that looking okay so far? Let me just double check. 2x, 2y prime, 2y squared, y squared, y prime, yep. So I want to get my y prime terms together, and again, the terms are everything that's multiplied. So 2x times 2y times y prime, that's one single term there. So I'm just going to keep that there. This one also is a single term. It's got a y prime in it. Okay, these are factors, so that still makes it one term. Okay, so those two terms I want to keep. This one I'm going to get rid of to the other side, so that's going to be minus 2y squared. So now I'm going to factor a y prime out. Listen, I'll maybe do one more step so you can see what's going on here. But this is 2 times 2, right, is 4, x, y, y prime, minus 3y squared y prime. Okay? So just you know, you could factor a y prime straight out of there, but make sure you remember that there's a 4xy left. So y prime, I got 4xy minus 3y squared. When I take these common factors out there, the common factor of y prime. So this is going to be 2x minus 2y squared. I can take some, I'm going to isolate this and then I'm going to factor. I'm going to do that, some factoring now. So this, I could take a 2 out of here, x minus y squared. And then this one that I'm dividing out, I could take a y out of there. So y, 4x minus 3y. Okay. Yeah, let's see. Yeah. Yeah, those, you can't divide the 2 and the y out at all, of course. Doesn't really help simplify too much, but having it factored with greatest common factors out is best. Now the x minus y squared, that's close, but there's no common factors there really. Okay, so that's the answer for F. Any questions? Any thoughts? Confidence level on this stuff, decent or what? 5 out of 5, 1 out of 5, where are we at? Seeing some fingers. Okay. Okay, all right. Yeah, question?
2y squared.
This?
In the top part.
Right here?
Yeah.
Or up here, you mean? This? So that's part of the, this is all part of the product rule for the first term.
You just mind breaking down that?
You bet, you bet.
Product rule of that.
So 2x times y squared, I broke that up into 2x as one kind of x function, and then y squared is the second y function. So you can't just take the derivative of the whole thing at once because you've got an x and a y in there. So I split that up into 2x and then y squared, and I did product rule. So the derivative of the first, which is 2x, is 2 times the second, y squared. So derivative of the first times the second plus the first, which is 2x, times the derivative of the second, which gets a little complicated here because it's a y. So it's 2y to the power of 1 times the chain rule, because this is a y function, so y prime. So I'll erase some of these circles now, and so you can kind of see. Okay, does that help?
Yeah, thank you.
Yeah, you bet. Anybody else? Questions about any of these so far from one? So that's 8F. I'll probably, yeah, there might be more. I think there's G and H, I guess. But I'll let you guys continue on to number 2 and 3 and so on. Okay.